Good morning to everyone. So in the last class, we discussed the basic properties in deflection of beams. Okay, so we discussed Bernoulli-Euler law, that is M equal to EI by R. Okay, and then from this we derived bending moment M equal to EI into d square y by dx square, and then shear force and intensity of loading. And then we discussed end conditions. Okay, so using this end condition, we can find the arbitrary constants which appear in the differential equation. So the first one is a freely supported end. So freely supported end, there is no deflection and no bending moment. Okay, then y equal to 0 and the second derivative is also 0. Suppose it is fixed, horizontally fixed, then deflection and the slope of the beam, both of them are 0. That is y and dy by dx is equal to 0. The perfectly free end, there is no bending moment. That is or shear force. The second derivative and third derivative is equal to 0. So in the table it is given, it is clearly embedded means fixed, horizontally fixed. So y equal to 0, dy by d, first derivative is also 0. So if it is a free means perfectly free. So second derivative and third derivatives are 0. Simply supported or hinged or freely supported. Okay, so don't confuse with freely supported and perfectly free. Okay, so should be a little bit careful. So it is simply supported or hinged or freely supported. Then you have y equal to 0 and the second derivative is also 0. And we discussed strut and 4 possible ways of the end fixation of a strut. Okay. I think I can. First problem. So the differential equation satisfied by a beam uniformly loaded W kg per meter with one end fixed and the second end subjected to tensile force capital P is given by EI equal to d square y by dx square equal to Py minus 1 by 2 into Wx square. Show that the elastic curve for the beam okay, with the conditions y equal to 0 and dy by dx is equal to 0 at x is equal to 0 is given by this equation. Otherwise they don't give this equation. Okay, just they will they'll ask find the equation of the elastic curve. Find the equation to the elastic curve. Elastic curve subject to the boundary condition. Y equal to 0 at x is equal to 0 and y and dy by dx is equal to 0 at x is equal to 0. Okay, solution. So what is given the question? EI equal EI into d square y by dx square equal to capital Py minus 1 by 2 into W. Okay, this is a W x square. Okay, now EI into d square y by dx square minus capital Py equal to minus 1 by 2 into w x square. Okay, this implies throughout divide by ei d square y by dx square minus p by ei into y equal to minus 1 by 2 into uh, w x square by e. So now rewrite this equation. This is a d square minus, okay, the next line, next page I will write d square minus p divided by ei into y. Okay, it's equal to uh, minus w by is equal to minus w by 2 ei into x square, where d square equal to d square by dx square. So now this is the second order differential equation with the constant coefficient. Auxiliary equation is m square minus p divided by ei equal to 0. So this implies m square equal to p by ei. So this implies m equal to plus or minus root of p by ei. So I will take this is equal to plus or minus n. Okay, where n square equal to p by ei. So m equal to plus or minus n. Okay, so and hence complementary function is c1 into e power nx plus c2 into e power minus nx. So now pi. So what is a pi? Pi equal to 1 by d square minus p divided by ei. Okay, into right hand side is what? Minus w by 2 ei into x square. So this is our algebraic function. So it is type 3. So we should write the denominator in the form of 1 plus x or 1 minus x. So p by ei is a constant. So let us take minus p by ei outside, which is equal to 1 by minus p by ei into 1 by, if you take minus p by ei, you get 1 minus remaining is what? Okay, d square so I'll take p by minus p by a, so that's why minus, the denominator will have p, the numerator is ei, into right hand side is what? Minus w by 2 ei into x square. So I think you can write this is ei gets cancelled, ei gets cancelled, minus into minus plus. Okay, w by 2p, w by 2p is a constant. Remaining, you can write 1 minus d square uh, d square by p into ei in the numerator. So whole power minus 1 into x square. So this is equal to w by 2p into 1 plus x. What is x? Ei by p into d square. This is x plus x square. X square is ei by p whole square into d square whole square. Okay, into x square. So please wait a minute. Just to continue, I'll come. I'll come within 2 minutes. Okay, now so w by 2p into, okay, we got this. After the expansion, we'll get this one. So w by 2p into multiply 1 into x square. Actually, I don't need this term. This is d power 4 of x square is 0. So d square of x square is 2. So 2 times e I by p. So now multiply throughout by w by 2p, you get w x square divided by 2p. 2 gets cancelled. So you'll get w e I p square. So this is the uh, PA. This is the PI. Now the general solution y equal to CF plus PI. Okay. So y equal to So CF is C1 into e power nx plus C2 into e power minus nx plus Pi. Pi is W by W x square by 2p plus W ei divided by p square. So we call this is equation number 1. So up to this, usually we will do up to this step. So now we need to find C1 and C2. So for this, they are given a condition here. When x is equal to 0, y equal to 0, and similarly when x is equal to 0, dy by dx 0. Okay, so here it is what, one fixed end. This side is what? This side is on fixed end. The second end is subjected to the tensile force. Okay. For fixed end, usually what is the boundary condition for fixed end? I think perfectly free. Clamped or fixed end, y equal to 0, dy by dx is equal to 0. But it is given here. This is x is equal to 0. This end is x is equal to 0. This end is x is equal to L. Okay. Now, when x is equal to 0, y is also 0. So using this condition, you will get 1 implies 0 equal to C1 plus C2. This is 0 plus WEI by P square. You call this is 2. Okay. Next, find dy by dx. Find dy by dx. If you differentiate equation 1 with respect to x, you will get nc1, or if you write nc1, you may think choosing n, is choosing 1 from n. Okay, it is better to write c1 into n into e power nx. Okay, and then minus c2 into n into e power minus nx. Okay, if you differentiate this, you'll get 2 gets cancelled. 2 gets cancelled. W x by p. W x by p. The last term is constant term. This is 0. Now there are one more condition. It is given the question. When x is equal to 0, dy by dx is equal to 0. So now, if you apply here, this is 3. Apply the condition here. 0 equal to C1 minus C2, not C1, NC1 minus NC, okay, NC2. This is 0. Okay, this implies NN gets cancelled. C1 equal to C2. So you got C1 equal to C2. Okay. Now, if you substitute C2 equal to C1 in equation 2, equation 2 implies, okay, C1 plus C2 is also C1, okay, plus WEI by P square equal to 0. From this, 2C1 equal to minus WEI by P, P of P square. P square. P square WEI by P square. Okay, but C1 equal to minus WEI by 2P square, which is equal to C2. But because we know that C1 equal to C2. Okay. Now, therefore, Y equal to, I am going to substitute the values of in the equation 1. Okay, the equation 1 implies Y equal to, I think C1 equal to C2. So that's why minus WEI by 2P square. This is for C1 and C2. C1 and this equation. So remaining you have what? E power nx plus e power minus nx. E power nx plus e power minus nx. Okay. Plus, so please check it, w x square by 2p plus w ei by p square. So now y equal to, you can write this is minus w ei by 2p square. This is okay. So including I'll write p square, e power nx plus e power minus nx by 2 is cos h nx. This is n, this is x, cos h nx plus wei by p square plus w x square by 2p. From these two, you can take commonly wei by p square. If you take commonly y equal to wei by p square, remaining we have 1 minus cos h nx plus wx square by 2p. So where n square equal to p by ea. So the problem is over. Okay, second problem. I think it is visible. Otherwise, okay, I will read again. The deflection of a strut of length L with one end x is equal to 0 built in, and the other supported, and the other is supported and subject to the end thrust capital P, satisfies the equation d square y by dx square plus a square y equal to a square into r by p into L minus x. I think the same problem you solved in the assignment. Is it correct? Those who
Yes.
submitted the assignment solved the problem. I think yesterday I checked 7 students are submitted. Okay, so still remaining students are working. I believe that they are working on the problems. Okay, I think this is the problem number 3. I think so. I don't know exactly. Okay, so if I solved this problem, I solved one of the problems from your assignment. Okay, so solution. So this is the diagram. Okay, So the one end, this the end x is equal to 0 is fixed. The other end is supported. Okay, supported. Okay, now uh, first write this equation: d square plus a square into y equal to a square r by capital P into L minus x equal to d square equal to d square by dx square. Auxiliary equation is m square plus a square equal to 0. So this implies m square equal to minus a square. This implies m equal to plus or minus I. So this is the roots. Now complementary function is equal to e power 0x into c1 into cos ax plus c2 into sin ax. Okay. Now we need to find pi. Pi equal to 1 by t square plus a square. Right hand side function is a square r by p into L minus x. Okay, so now this is algebraic. L minus x is algebraic. So you should write the denominator in the form of 1 plus x or 1 minus x. So this is a square r by p is constant. We'll write, take a square is common. So 1 plus d square by a square into L minus x. So a square gets cancelled. You'll get r by p into 1 plus d square by a square whole power minus 1 into L minus x, okay, which is equal to r by p, okay, 1 minus d square by a square. Even I don't need d square by a square uh, because here we have x. So pi is r by p into L minus x. 1 into L minus x is L minus x. D square of L minus x is 0. So this is your pi. So now general solution is y equal to cf plus pi c1 into cos ax plus c2 into sin ax plus r by p into L minus x. So this is equation 1. Okay, now so next we need to find the constant c1 and c2. So for this, so again read the question carefully. With one end x is equal to 0 is built in. Built in means fixed end. Okay. So first, as the end x is equal to 0 is built in horizontally. Okay. So now you should tell the condition. As the end x is equal to 0 is built in, built in, comma, that. So what is the condition for fixed end?
Y equal to 0 and x equal to 0 and dy by dx equal to 0 and x equal to 0.
Yes, correct, Pragdish. As the end x is equal to 0 is built in, okay, comma, the deflection deflection y and the slope of deflection curve. The slope of deflection curve are both 0. Okay, so therefore y equal to 0 when the fixed end, that is x is equal to 0. Similarly, subdivision 2 dy by dx is equal to 0 when x is equal to 0. So using 1, okay, using subdivision 1 and the subdivision 2, first subdivision 1, okay, if I use subdivision 1, we'll get 0 equal to, okay, when x is equal to 0 means cos 0 1 c1 plus sin 0 0, x is equal to 0 means rl by p, rl by p. This implies a c1 equal to minus rl by capital P. So we got the c1. So to find the c2, now I need to find the dy by dx. Okay. So if you differentiate 1 with respect to x, you get dy by dx equal to, if you differentiate with respect to s, you get minus a c1, minus a c1 into sin ax, okay, plus a c2 into cos ax, and if you differentiate x, you get minus r by p. Okay, now you should use the condition, second condition, using 2, using subdivision 2, 0 equal to, this is 0, plus ac2 minus r by p. So from this c2 equal to r by p into a. So this implies c2 equal to r by ap. So this implies equation 1 implies, now I'm going to substitute the value of c1 and c2. So c1 is minus r by p, minus r by p into cos ax, plus c2 is r by capital R by ap into sin ax, okay, plus r by p into L minus x. Okay, this is, I call this is equation number 2. Okay. So now, uh, now, but they're asking what? They're asking, the question is, suppose if they're asking like this, we know that we need to do up to this step. But they're asking, prove that the deflection curve is y equal to r by p in this form, they're asking. So here also L, you have L cos AX, L minus X. Okay. So this is the indicator uh, we need to use the boundary condition at X is equal to L. Okay. Uh, since the other end, X is equal to L is freely supported. That is given the question. Okay. So if it is a freely supported means, can anyone tell what is the condition? Ramalingam? Is Ramalingam is there?
Yes, sir.
Okay. If you know, you can tell. Otherwise, no problem.
Y double dash equal to 0 and y triple dash equal to 0.
Check Pallama.
Yes, sir.
Okay. Y double dash, Y triple dash, if it is free, okay, free means like this, okay, that is called free end. But I told that freely supported means like this, okay.
Okay.
uh, so that's why I told that there is a difference between perfectly free means this is perfectly free, freely supported means this is freely supported. So freely supported is also same as simply supported. Simply supported or freely supported are same. So simply supported, what is the condition? Y equal to 0 and y double dash is equal to 0. Okay. So thank you. Answer தப்பா பண்ணாலும் பரவாயில்ல. At least you replied something. Okay. Since the other end x is equal to L is freely supported, y equal to 0 at x is equal to L. And I don't need the second condition. So we don't need the other condition. Need the other condition. D square y by dx square equal to 0. Okay. Now, equation 2 implies, so y equal to 0 at x is equal to L. So 0 equal to minus r by p cos AL plus r by AP sin AL plus r by p. Uh, X is equal to L means 0. This is 0. Okay. So this implies R by AP sin AL equal to R by P cos AL. R by AP sin AL equal to RL by P into cos AL. So RR gets cancelled, PP gets cancelled. Uh, so sin AL by cos AL, that is a tan AL equal to AL. Okay. So hence the deflection curve is given by deflection curve is given by y equal to r by p. Okay, you can take r by p commonly. Okay, throughout you can take r by p commonly. Okay, sin ax by a minus okay, I need L cos AL. Okay, I think equation 2, I think there is some mistake here. One implies what is one? One is
RLP, sir.
RLP. Sanjaya.
Yes, sir.
Okay. முன்னாடியே சொல்லிருக்கலாமே. Thank you. Y equal to minus RL by P cos AX plus R by AP sin AX plus R by P into L minus X. Okay. And then here also RL. Okay. So the next step here also RL. So now RL can cancel RL. L is also cancel. L cancel on a problem varume.
Sir, cost only RLBP, sir.
Here only RL la. Okay. Cost மட்டும்தான் இங்க கிடையாது. பட் எப்படி கரெக்டா இங்க L போடுங்க. இதெல்லாம் விட்டுட்டு சரி ஓகே minus RL by P R by AP sin AL equal to RL by P into cos AL. Okay. So now equation 1. What is equation 2? Why in equation 2 I am taking commonly R by P. Okay. So if I take commonly R by P, what is remaining? Please check it. Sin AX by A. Okay. And then minus L cos AX. Minus L cos AX. And then plus L minus X. So this is Y. Where AL equal to tan AL. So please check it. I think this is you need to prove. So the deflection curve is equal to this expression where AL equal to tan AL. Okay. So now third problem. Please write the third problem. A concentrated vertical load. Okay. Okay, I will give this problem as a practice problem. I will solve this problem. Okay, for a beam of length L, for a beam of length L, clamped at one end, x is equal to 0, and freely supported at the same level at the same level at the other end. Comma, with a uniformly distributed load omega per unit length per unit length, comma, it is known that EI into d square y by dx square is equal to 1 by 8 omega L square minus 5 by 8 omega Lx plus 1 by 2 into omega x square. Find the equation of the deflection curve. Find the equation of the deflection curve. And prove that, okay, I don't give the question like this. Find the equation of the deflection curve, okay, full stop, and find the maximum, and find the point in which maximum deflection occurs, and find the point in which maximum deflection occurs. Okay, this is the question. Okay. So the given differential equation is the given differential equation is EI into d square y by dx square, which is equal to 1 by 8 into omega L square minus 5 by 8 omega Lx plus 1 by 2 into omega x square. I call this is equation 1. Okay, so again I'll read the question. For a beam of length L clamped at one end x is equal to 0 and x equal to 0 is clamped, that means fixed, and freely supported at the same level at the other end. At the other end means x is equal to L. It's a freely supported with the uniform distributed load omega per unit length. It is known that this equation, find the equation of the deflection curve, okay, and find the point in which maximum deflection occurs. So that means this is the hint. Okay, you need to find y. Okay, so you need to find y. The reason is you need to find maximum deflection. So the maximum deflection of y occurs only if dy by dx is equal to 0. So for this, now I am going to find y. So but here you have d square y by dx square. So first, if you integrate with respect to x, if you integrate with respect to x, you'll get integrate integrating 1 with respect to x, will get ei into dy by dx equal to 1 by 8 w or omega l square into x minus 5 omega l into x square by 16 plus omega x cube by 6 plus a. I call this is equation 2. So I need to find the constant a. Okay. So for this, I am going to use the end condition. The end x is equal to 0 of the beam is clamped. Okay. Therefore, uh, what is the end condition? Yashashwini, can you tell?
dy by dx is 0.
Dy by dx is equal to 0. Yes, correct. So therefore, when x is equal to 0, dy by dx is equal to 0. Okay. So, but there is one more condition. Okay, for fixed end, but I need only this because I have here only dy by dx. Okay, when x is equal to 0, dy by dx equal to 0. So if you substitute here 0 in equation 2, 0 equal to this x is 0 and this is also 0, this is also 0. So a is 0. It implies a is 0. So if you substitute a equal to 0 here, you will get I'll take this is 3. So using 3 in 2, you'll get 2 implies ei into dy by dx equal to 1 by 8 into omega l square x minus 5 by 16 into omega l x square plus omega x cube by 6, a equal to 0. I call this is equation 4. So again integrate equation 4 with respect to x. If I solve this problem, again I solved one of the problems from the assignment 2. Okay. You can check. Not uh, not the same problem. That problem is a particular case of this problem. You can verify. Okay. So now, if we integrate with respect to x, integrate with respect to x, ei into y, ei into y equal to Right hand side is what? W L square x square by 16. W or omega L square x square by 16 minus 5 W omega L x cube by 48. So finally you have omega x power 4 by 6 into 4, 24 plus a constant b. So I need to find the constant b. Okay, I call this is equation 5. So for this also I am going to use the condition, the end x is equal to 0 is clamped. That means fixed. Therefore, when x is equal to when x is equal to 0, Lakshmi Narayanan, when x is equal to 0, what is y?
V by EA, sir.
I'm asking the condition when x is equal to 0. For I think here we used one condition when x is equal to 0, that this entity is clamped. X is equal to 0, this entity is clamped or fixed. First derivative 0. Okay. Similarly, I'm asking the end of x is equal to 0. Y is what? It is the fixer. Then a fixer means embedded. Y equal to 0 and y dash is equal to 0. It's a boundary condition. Is it correct, Lakshmi Narayanan?
Yes, sir.
Okay. So y is equal to 0. So I call this is equation 6. Okay. Similarly, the end x is equal to L is Nandini, can you tell x is equal to L in the question is what? Are fixed free and freely supported?
Freely supported.
Yes, freely supported is correct. If it is freely supported, then Kirtana will tell what is the boundary condition when x is equal to L. What is y?
Uh, y double dash will be equals to 0.
I don't need the condition y double dash. One more condition.
Uh, y equals to 0.
Y equal to 0. Okay. So that is okay. Thank you. Now, okay. My question is, if I apply either 6 or 7 in 5. Suppose if I apply 6, this is 0, 0, x 0, x 0, will get a b equal to 0. If I apply 6, what happened if we apply 7 here? This is 0. This is what? W or omega L power 4 by 16 minus 5 omega 5 power 4 by 48 plus 5, sorry, not 5, omega L power 4 by 24. So add these two. You can take commonly 48. 48. This is the 3 times. This is 2 times. So 5 times omega L power 4. This is minus 5 times omega L power 4 by 48. So either if you apply condition 6 in 5, or if you apply condition 7 in 5, you'll get B equal to 0. So using 6 or 7 in 5, we get B equal to 0. So now substitute B equal to 0 in equation 5. 5 implies EI into Y equal to 1 by 16 omega L square x square minus 5 by 48 omega L into x cube plus 1 by 24 into omega x power 4. Okay. So which is the required equation of the elastic curve? Which is the required equation of the deflection curve or elastic curve? Equation of the deflection curve. Deflection or elastic. Okay. So now we need to find the second part. Find the we need to find the second part. What is the second part? Find the point in which maximum deflection occurs. So since one end is clamped and the other end is freely supported, comma, the maximum deflection deflection does not occur at the midpoint. At the midpoint of the beam. So the deflection Y is maximum the deflection Y is maximum when dy by dx is equal to 0. Okay. So therefore the maximum point is given by the maximum point is is given by, okay, what is equation y? So here you have, okay, so the deflection y is maximum when dy by dx is equal to 0. So now I am going to substitute dy by dx is equal to 0 here. If I substitute dy by dx is equal to 0, then you have 1 by 8. This expression is equal to 0. Okay, so therefore the maximum point is given by 1 by 8 into omega L square x minus 5 by 16 omega L x square plus 1 by 6 omega x cube equal to 0 by using equation 4. By using equation 4. Because when dy by dx is equal to 0, so then you can equate dy by dx is equal to 0. Now take 8, 16, 6. So take 48 is LCM. So here have 6 omega L square x minus 3 times 15 omega L x square and then 48 8 omega x cube equal to 0. So just cross multiply and take x commonly from the numerator. You'll get a quadratic equation 8 omega x square minus 15 omega L x plus 6 omega L square equal to 0. So therefore either x is equal to 0 or this expression equal to 0. Okay, so if this expression equal to 0 means it's a quadratic equation minus b means w omega L plus b plus or minus root of b square. B square is 15 square is 225 omega square L square minus 4 AC minus 4 AC. Okay, 4 into 8 into 6, 32 into 6. So 32, correct, 4 AC. Okay. Okay, 192. 192 omega square L square divided by 2A. So 2 into 8 omega is 16 omega. The numerator is 15 omega L plus or minus. If you take omega square L square from the root, you'll have 225 minus 192 into omega L divided by 16 omega. So you take commonly omega, okay, and then take commonly omega and then cancel omega. So the remaining is what? 15. Okay. L you can take common, L by 16. L by 16. Omega is cancelled. Remaining is here you have 15 plus or minus root of 25, 8, 33. So this is x. So now there are three possibilities. X is equal to 0, x is equal to L by 16 into 15 plus root 33 and minus root 33. Okay, so now the question is, out of these three, which is at which point is it attains a maximum value. So here I already told that since one end is clamped and the other end is freely supported, okay, maximum deflection does not occurs uh, uh, at the midpoint. Okay, so the deflection y is maximum when dy by dx equal to 0. So now the question is the maximum deflection occurs either x is equal to 0 or x is equal to 15 plus or minus. Out of these three, which one? Why the remaining two is not? You should tell the reason also. Anybody? So if you tell the answer, then this class is over.
By 60 into 15 plus.
Should you please tell little bit loudly? I am not getting properly.
L by 16 into 15 plus 30.
Plus, you are telling plus is the correct one, na?
Yes, sir.
Okay. Should answer is plus. Okay. So I am expecting somebody's answer, some other answer. Look at the carefully this one. Okay, you can easily neglect x equal to 0. The reason is x equal to 0 because that end is clamped. Okay, so the maximum deflection will not occur there. I will, okay, so I eliminated x equal to 0. Only you have two options. Okay, so out of two options, plus will not come, minus will come. Why plus will not come? I know that if you try that you can tell. You have the capability. So I okay. Otherwise, I'll give you one
Not
more.
exceed
It
the
will
length
cross
of
the limit of L, sir.
the L value.
Sorry. X is the
If it is plus, then it will increase. It will go beyond the value of L.
very good. It is beyond the beam. Okay, va? So actually, I think Paraswaran also gave the same answer. So if you tell the answer, don't immediately mute because just will wait because sometimes I'm not getting your answer correctly. So it is given that the length of the beam is L here. Length of the beam is L. This point is 15 plus root 33 means it is exceeds 16. Okay, root 33 means around 5 point something. So it is a 20 point something. So 20 divided by 16 is more than 1. So it is more than L. Okay, so it is beyond the point x is not in the beam. So and hence x is equal to L by 16. 15 minus root 33 is the correct answer. Okay, good. Uh, okay. I will finish it. I will finish it here. Clearly, x is equal to 0 is uh, not the maximum point. And the point, x is equal to L by 16 into 15 plus root 33 is not a point on the beam. Therefore, so maximum deflection occurs at x is equal to L by 16 into 15 minus 33. Actually, this is the first assignment problem. Sorry, this is the in assignment 2. There is in big question. There is a first problem. You can check it. That problem is a particular case of this problem. So you can try that problem without seeing the procedure for this one. Okay, thank you. If you have any doubts, ask to me. Otherwise, we'll meet on coming Monday, 4th hour. Okay, thank you. Thank you, everyone.
Thank you, sir.
Thank you, sir.
Thank you. Thank you.
Thank you, sir.
Thank you.
Sir,
Lakshminarayan, சொல்லுப்பா.
sir, what is the EI in the first sum, sir?
EI எந்த இடத்துல கேட்குற ஃபர்ஸ்ட் ப்ராப்ளமா?
Yes, sir.
இந்த இதுலையா இங்கேயா?
இல்ல சார், ஃபர்ஸ்ட் ப்ராப்ளம்ல சார்.
ஃபர்ஸ்ட் ப்ராப்ளம். இங்கேயா? இங்க கேட்குறியா EI?
Yes, sir.
EI yesterday I gave E is what? E is modulus of elasticity of the beam. I is the moment of inertia of the cross section of the beam about neutral axis. இங்கே நான் சொல்றேன் ஆரம்பத்திலே சொல்லிருக்கிறேன். M equal to EI by R. E is the modulus of elasticity of the beam. I is the moment of inertia of the cross section about AA dash. AA dashங்கிறது, so this is the line AA dash. ஓகேவா? அல்ல வேற என்ன ஏதாவது டவுட்?
ஓகே சார்.
சரி.
ஓகே சார். தேங்க்யூ சார்.
தேங்க்யூ.